All right. So malware analysis in virtual machines is, of course, what you have to do. So you're going to run malware deliberately, infect the machine to see what happens, and this is dynamic analysis. We need to do it, but therefore we have to have a safe environment. So the most safe environment, we would have a real machine with no network connection, but in practice, it's good enough to just use a virtual machine. In principle, some malware detect virtual machines and not run properly, but this is not common with Windows malware. It is universal with Android malware, however. If you try to analyze Android malware, you have to have a physical Android device. It detects the virtual machine and won't run in there. So you run a virtual machine, and therefore that'll protect the host machine from the malware, except there are some exploits that escape from the VM onto the host, but they're not common. So you can get VMware Workstation Player or VMware Fusion Player for free, or you can use VirtualBox or anything. I prefer VMware, but whatever you like. So you can configure it to not be connected to the internet, although I usually don't bother, just connect it to the internet, don't worry about it. Go through the default networking, which is network address translation, which puts it on a different subnet than the host. So, all right. Now, if you want to, you can isolate your virtual machine so they can't get to the internet, but this will typically mess up the malware because the malware is going to try and phone home. And there was a lively discussion about this at an event I went to with a European agency, malware research. The Europeans felt very much like you should avoid this, and the Americans said, just let it phone home, make another bot. They said, but you'll get blacklisted for having infected machines. They say, who cares? Just trying to get the job done. And I take that attitude like most Americans. Fast and sloppy and convenient is probably the best answer. All right, you can take snapshots of your virtual machine before executing the malware to recover from it. That's a good practice. I think you have to have the pay version of VMware to do that, but it might be available in the free version by now. Let me check. I think I see more comments here. No, okay, the same old stuff. All right, yeah.
In terms of the allowing it onto the network, is there any concern that it would, I think Warren's last time we talked about it was one of those.
Well, you could worry about that. It might try and reproduce over the network. Typically, Windows malware can't do that unless you got an old unpatched vulnerability.
Okay.
Typically, you'd have to trick somebody into running it. So that's why it's not usually a big concern, but it can happen.
Okay.
Yeah. Good. All right. And so there's risks. It might run differently. VMware might crash it, or it might spread to the host. All the textbook samples we're using are harmless. They just simulate malware. They're not real malware that spreads. All right. Anyway, so dynamic analysis is, like I say, an amazingly sloppy, easy process. When I first heard about it, you run a bunch of analysis tools on the compromised system. Then you run malware on that system. Then you see what the tools are saying to you. My first thought is, this is stupid. How can you trust anything that comes from a compromised system? But in practice, most of the time you can. So, and none of your techniques are perfect. So if your static analysis doesn't solve your problem, which is very common, especially with the simple static analysis tools, then you do dynamic analysis to see what happens. And by the way, there are a bunch of automated sandboxes to do it for you now, online. Things like Norman Sandbox and Joe Sandbox, they'll just run it, and if you go to VirusTotal, and they know about the virus, they will actually run into the virtual machine, record the network traffic and the processes and the registry keys, and you can just see them right there. They do all the stuff we're going to do manually, automatically, and just present the results. So, all right. What's that? Yeah, VirusTotal does it. Yep. If you search for a virus that's up there, you can often find a sandbox output on one of the tabs. It's very nice. All right, so you run your malware. You can run EXEs directly. If you want to run a DIL without an EXE, there's a run DIL program just for that purpose, which you can use to execute because DILs are libraries, and libraries can't run by themselves. They need an EXE to run them. And then you tell it which function you want to run. So each library has a bunch of functions, and so you use run DIL to run this library, this function, and you can run the functions one by one if you want to do that. I've never had to do that, but it is an option. So if you have the install, uninstall, and uninstall, you could run this on install to install it, that sort of thing. Some functions use numbers instead of their names, and we'll see that as we go later in the course and start analyzing libraries. And then there's Process Monitor, which is extremely useful. Process Monitor is just a souped-up version of Task Manager, and a Task Manager keeps getting more and more features. Since Microsoft bought sysinternals, they're building more and more of the sysinternals tools into Windows. And so it shows you all sorts of activities. I got it wrong again. Process Explorer is the one that's a souped-up version of Task Manager. Process Monitor is a special tool that records events. What it is another window into Event Viewer. Now, if you used Microsoft Event Viewer, you will have discovered that it is bafflingly complicated and hard to use. Thousands of events from the simplest activity, sorted into many categories with confusing names, so that people invent tools just to make it easier, and that's what Process Monitor is. Process Monitor just lets you see the events in Event Viewer, but it shows you the significant events, like a file opened, a process launched, a registry key created, and things like that. So it looks like this. So if you just launch calc.exe, you still have many events, but see, it shows me it opened a key, it closed a file, it read a file, it created a file, things like that. So meaningful events. And you can start and stop the capture with the magnifying glass, which is a mighty strange thing to use for start and stop. And then you can filter it with this thing that looks like a filter, which is what you have to do because there are so many events going on in your machine. You have to filter out all the boring events to focus in on the interesting ones. And we'll do this in the projects later. So one technique is hide all the normal activity, then run the malware, and that's fine. Another simpler way, which is sloppier, is to just only include the name of the malware. Now, if the malware was to launch other processes with different names, you wouldn't pick them up. But anyway, all right, we'll play with that. And then Process Explorer. Process Explorer is the souped-up version of Task Manager, and what it does is it shows you all the processes on your machine from launch. And from your machine's first launches, this is kernel land up here. These are the processes that run before you log in. So they have to run with a high privileged account like installer or system because you haven't logged in yet. And this is where it launches all the services that run in the background, which run as service host mostly. So these, and then if you scroll down to the bottom, you'll see the user land processes. So services are pink, processes are blue, new processes are green. When they terminate, they turn red before they vanish. And you can also view the libraries used by every process. So here you can just use a lower pane view, and here I've selected one of these Chrome processes, and down here you see all the libraries that Chrome is using. You can also see all the handles that it's using. Handles are references to objects, like a file open handle or other object. There are many handles used in processes, and you usually don't mess with them. You can also see whether the process is running with data execution prevention or address space layout randomization. Almost everything is these days. Address space layout randomization means every time this process launches, it will randomly relocate in memory. And data execution prevention means that the stack of this process is marked non-executable. Both of those prevent attacks of the types that we'll be doing in oh my, and it's funny, the stupid voice sensor keeps going off on my wristwatch trying to look things up, so I haven't figured out how to disable it yet. It's constantly coming on trying to narrate me talking. Anyway, all right. And so then you can look at strings. There's a strings tab. You can look right at the strings in here. These are just the readable strings. One thing, you can look at the strings in the image on hard drive, or you can look at the strings in memory. They should be the same. If they aren't, you've got process replacement. You can run a process, and then you can change the RAM so it continues running with the old privileges, but now it does something different. Normally, launching something from a disk file to RAM is just a matter of copying sections, literally up into RAM and running them. But you can perform this attack called process replacement where you change the running code, which is pretty cool. And if that happens, then the strings in RAM won't match the strings on the disk. Let me check for comments. The quizzes are in Canvas, and you get the Canvas from samsclass.info. Anyway, the free version does give the option for snapshot now. That's good. All right. Don't know if you have Apple. I do have Apple Watch. Settings, Siri, good, okay. Thanks for telling me. I'll try that again. I tried to turn it off before, but somehow it's on again. Anyway, I've never used any of these voice things. They all seem useless. Irritation as far as I can tell, but anyway. All right. And so you can open a document with a vulnerable application and see if it launches a process. This is one way you can detect malicious documents like PDF and Word documents. if they're going to launch another process. And there's this thing called red shot you can use to observe changes in the registry. It's clumsy to use, and I haven't really used it that much, but you can run this thing and take a first shot, then run the malware, take a second shot, and then you can compare them. It will show you the registry keys that were changed. I prefer to find this in Process Monitor, but you can do it with red shot also. And you can also make a fake internet, another thing I've almost never bothered to do. Like most Americans, I just let my malware talk to the real internet, which is sloppy, but you could use INetSim, which is a program included in Kali Linux that simulates the internet, including all the services that might be there, so that it can load an page of HTTP. Now, it's not going to find the command and control server. It'll just be loading a standard page, but at least you can make the network connection you can watch to see if it's doing that in a more sanitary way. You can also make a listener with NCAT. That's another way to do it. This is a much simpler process than using INetSim, which simulates a whole lot of listening ports and actually has appropriate banners and stuff to masquerade as these services. But you can monitor with NCAT. So if you try to go to a web page, 127.0.0.1, up here I'm running an NCAT listener, and so it receives the GET, but it doesn't reply with the web page because it's not really running a web server. So it gets to do the TCP handshake and it receives the signal, but then it doesn't get a good response. So you could get some information by this kind of networking, but like I say, and typically you just want to let it go to the real internet to get the real story of what that malware is going to do. Then you can sniff it with Wireshark, which we're going to do in the project later to see what traffic is being set off by the malware. And you can follow a TCP stream to see the contents of traffic. So here it is getting something and getting a reply and having a ping image here. That's a binary image coming down. So we'll play with that stuff a little later. And there's INetSim. I don't think I'm going to worry about it much. It just has a default HTML page. It's listing out a bunch of ports. When you scan it with Nmap, you find all sorts of things open. It's simulating all the common ports on the internet. All right, so Procmon. Main thing is, simplest thing is just filter on the malware executable name. So you see only the information from that executable. That's the easiest way to do it. Process Explorer and Wireshark. These are the three we're going to use. These others, I'm not that excited about. Red Shart and INetSim. I did them a few times, but they seem more trouble than they're worth. So, all right. Let me try a Kahoot, and then I'll get into demonstrating projects, which is the main thing today. The Kahoots are here. I got to open a page. All right. $126. Oh, there's part of a previous chapter I was supposed to cover today. I'll go back and do that. All right. All right. All right, Which method will make malware smaller? Yeah, it's packing, like zipping, makes it smaller and conceals the strings. All right, so what type of file must be executed using Rundell 32? Who's buried at Grant's tomb? Those, of course, dynamic link libraries. All right, what tool records thousands of events so you must exclude most of them? What's that? Do you get what? It's easy to get it. Yes, I often get it backwards. So do students. Process monitor is the one that does that. All these events going by. All right, which tool shows individual Ethernet frames? Wireshark. All right. There's a Microsoft product called Netmon or something, but it's garbage and nobody uses it. Everybody uses Wireshark, unless you're a total Microsoft fanboy. Anyway. All right, what tool allows you to analyze botnet malware without contacting a real command and control server? That's INET SIM, of course. All right. And that's malware, real name. Another real name, good. All right. Well, I'm going to stop this recording.